for the given solid, calculate the surface area, volume and the mass, given that we're told it has a density of 6.7 grams per centimetre cubed. So this is kind of like a plumb bob, something that kind of hangs on a piece of string to keep the string level, that sort of thing, maybe made of iron, something like that, although we don't know the density of iron. But this is a compound shape and it's made up of 3 different parts. So the first bit here, the kind of domey end, well, that's a hemisphere, it's half a sphere. The bit in the middle, so this tubey bit, that is a cylinder. We don't have to worry about the ends of the cylinder for surface area because they're not included on the outside of the shape. And then you've got a cone at the end, and again you don't have to worry about the bottom of the hemisphere or the ends of the cylinder or the bottom of the cone, because all of that is inside the shape, not on the outside, and it wouldn't make a difference to volume anyway. So if we start with surface area, so we know that the surface area of a cone, and I'm just taking all of this from the formula sheet, equals pi RL, where L is the slanting length. So R we sort of have R. We've got this 10 centimeters here, which is basically all the way across. If I kind of draw a line like that, then R is going to be 5. So R is no problem. I've got R. L I do not have. L is this length here. So it's kind of this slanting length. That I'm going to need to find. I'm told that this is 8. I know that this is 5. So for L, I'm going to have to do a bit of work. So let's actually just do that now. So this is half a cone. So I'm just drawing that. What that corresponds to is this triangle kind of round here. Something like that. Where this is 5 because it's half of 10. Radius is 5. This is 8 because this is 8. And L's the bit we need to find. So we've got 8 cm, 5 cm and L cm. Right, so it's Pythagoras. We're looking for the long side, so short side squared plus short side squared equals long side squared. So 5 squared plus 8 squared equals L squared. Should have done that over here really. Well, 5 squared is 25 plus 64 equals L squared. So now we're going to have to move over here. Well, 25 plus 64 is 89, so L squared equals 89. L must equal root 89. And I would leave it in that form for now. We're only going to have to use that L for calculation, so it's much neater like that once we put it into the calculator. So we're good for the cone. We've got pi, well, pi is just pi. We've got R, we've got L. So we need now the SA, surface area of a hemisphere. Well, the surface area of a sphere, if you look in your formula sheet, it's 4 pi r squared. So a hemisphere is half a sphere, so 4 pi r squared over 2. Well, 4 pi r squared divided by 2 must just be 2 pi r squared. 2 pi r squared. We do not need to worry about the bottom of the hemisphere because it's not on the outside of the shape, so no problem. So we have r and pi is just a number, so that's fine. And then we have surface area of the cylinder, and we only need the curved surface area, which is all that, I think that's all the formula sheet gives you, but it's the 2 pi r h, 2 pi r h, where r's the radius, so r is going to be this 5 again, h is this 12. 2 pi r, remember, it's the circumference, it's the distance that cylinder wraps around. So we have r, we have h. So overall the surface area equals, well, it's pi rl plus 2 pi rh plus 2 pi r squared for the hemisphere. So if we substitute in for that, what that is going to be pi times r, well, r was 5, times L we worked out for root 89 as root 89, plus 2 pi times R, still 5. H, remember H is the height of the cylinder, that's 12, plus 2 pi R squared. R is 5 for all 3 shapes. So all of that. Now I'm not going to show you me putting it into the calculator, but I would encourage you to make sure you get the same answer for yourself. I've checked that this is right, but you've all got different calculators, varying calculators. Make sure you can get to this number. If you can't, you need to make sure you know what your mistake is. So this should be 682.2593802. We haven't been asked for a degree of accuracy, so I'm going to go 3 significant figures. So 1, 2, the third significant figure is this 2. Next to that is another 2, which won't do anything, so we'll chop everything else off. Equals 682 cm squared to 3sf. I know it is centimeters squared. It is a surface area. Okay, now for the volume of the shape. And volume should be a bit easier than the surface area, hopefully. So, looking at the formula sheet, the volume of a cone equals 1/3 pi r squared h. So pi is just a pi. We have r. We know it's 5. We have h. Well, the h is the height of the cone, which is this 8. So we've got r. We've got h. That's fine. The volume of a cylinder equals pi r squared h, because it's a prism. So pi is pi, r is 5, h is the height of the prism, which is 12, so that's fine. And then the volume of a hemisphere, well, if you look in your formula sheet, it tells you the volume of a sphere is 4/3 pi r cubed. So the volume of a hemisphere must be a half of that. So it's like it's a half of. So of means times. Half of 4/3 pi r cubed. So you could think of that as 2/3 of pi r cubed. But if you just want to do 4/3 pi r cubed and then divide by 2 or times by a half, that's fine too. Okay, so volume, we'll just do it all as one expression, I think. So volume equals, well, we'll do the cone first, 1/3 pi r squared h, so 1/3 pi times r squared is 5 squared times h, we said was 8, plus, remember that's the cone, plus we'll do the cylinder next, which was pi r squared h, so that would be plus pi times 5 squared. H is a different h for the cylinder, it's 12 for the cylinder, times 12, plus, that was the cylinder, plus, so for the hemisphere, we decided it was 2/3 pi r cubed, so 2/3 pi times 5 cubed. So, as I said in the previous one, I'm not going to show you the calculation, but you do need to do this calculation for yourself and make sure you get the same number. It's actually doing the calculation is often the source of the error. I've seen it happen so many times. So that should come out as 1413.716694 and so on. Write the long number, but then we do need to round that. So we haven't been told what to round to, so we will do 3 significant figures. So 1, 2, 3. The third significant figure is the 1. You look next to the 1, it's a 3. The 3 will not change the 1, so it's going to be equals 141, but we do need a placeholder, so 1410, and the units are centimeters cubed, so 3 significant figures. Right, so the last part, so part C, that was part B. Part C is asking me for the mass when it tells me the density. So it tells me that 1 centimeter, 1 cm cubed weighs or has a mass of 6.7 grams. So we want to know what 1413.716694 what that many centimeters cubed must weigh or have a mass of, be more correct. The science teachers wouldn't like me saying weighs. So that weighs question mark. So if you look at it, this is another kind of proportion cell. Basically, I can just multiply. To get from left to right, I can multiply by 6.7. So I take this number and times it by 6.7. Or you could say to get from the top to bottom, I times by 1413. Either way, I need to do 6.7 times this 1413, and you should be using the long number really. Now technically in an exam paper they might let you, say you use your answer to part B as in the rounded version, you might get away with that, but really there is an accuracy issue in here as well. You should be using the accurate version of the number in a calculation. I would imagine on your calculator you probably, if you've done it, you should have this in as your last answer anyway, in which case you can use the ANS button. I wouldn't write it down as working, but if you use this ANS button, which is near the equals sign, you press shift to get it usually, then that will just use your last answer. But what I'm going to do instead, I'm going to do 6.7 times 1413.716694. If you do that, you should get 9471.9-ish, so on. Right, so that is equals 3 significant figures, so 9470 grams, or I suppose you could call it 9.47 kilograms. I can't put it in kg, something like that. So the key things really, I mean, I think knowing the formula, knowing how to use the formulas, that is, yes, it's not easy, but hopefully with enough practice you're getting somewhere on that. Don't take it for granted that you can just do the calculation. Putting this into a calculator and getting it right is a skill in itself, or at least it needs careful, needs concentration, care and attention to get it right. And remember, if you're using a number in a calculation, use the most accurate version of it you have. If it's a surd, keep it as a surd. If it is a long decimal, then use the long decimal. Hopefully you can avoid typing it by using this ANS button.